Hi, in this video, I will walk you through the electric motor testing and characterization lab unit that is developed by Decibels Lab. We can call this test setup as a motor testing dynamometer. With the help of this test setup, we can actually conduct various different type of tests to study the characteristics of an electric motor. Typically, this kind of a test setup is used to study a specific performance characteristics, efficiency characteristics, maybe even the continuous performance of the motor that may be currently available in the open market. Or in case, let's say for a company who is developing a new motor, even they can use this test setups to study the behavior of the motor that they would have developed. And also as a part of it, this test setup can be used as well when somebody is developing a motor controller algorithms or a motor controller hardware such as power electronics devices. So henceforth, we can use this test setups for various different experimental purposes. To make this happen, we have a set of hardware. The hardware of this motor testing and characterization unit consists of a motor under load and the load that will recreate the real-time forces that can act on the motor under test. To measure the motor parameters, we have a torque sensor, an inline torque sensor, which will measure the torque and will give you as a feedback to the test software. When we conduct an experiment, so we need to have a setup that powers up both of the motors, one that is motor under test and also the absorber or a motor load. For this purpose, we have a staged power electronics units that are sitting in the bottom, which will take care of absorbing or supplying the power that is required to run this motor or that is produced by the load on the other side. To make this test setup works in a synchronized manner, we have a testing software. With the help of this testing software, we are able to conduct or initialize various testing sequences. For example, you want to conduct a test at a specific speed with a specific load in place. We can set that parameter through the help of this software that will interface completely with the test bed which is right here. And also as a part of this software, we can even acquire the data. We can plot all the data that is coming from the test bed, such as the torque, RPM, percentage of throttle, the motor speed, the motor current, the motor voltage. Also in the future, we will be adding the phase currents and phase voltages as well as a part of the equipment. So henceforth, when we study the test setup, we can get to know what is your DC bus input to the motor, output of the motor controller to the motor, and also a mechanical output of the motor. Henceforth, we can study the DC current, I would say DC power that is going into the motor controller. And also as an output of the motor controller, you would have a phase voltages that is going to the motor. We can measure that, we get to know what is the efficiency of the motor controller. And then from that phase inputs, the mechanical output that is given by the motor, as we measure the motor speed and the motor torque, we'll be able to also calculate the output mechanical power of the motor. Henceforth, we get to know what is the motor efficiency as well. And when we subject the motor to different load conditions, we can get to know its efficiency at different range of its speed and torque. And we can map the overall efficiency of the motor as well. So henceforth, with the help of the software and the help of the hardware, this test setup enables an engineering activities to study the motor and its characteristics, and also to help you to develop, in case of power electronic devices such as inverter circuits, or also if you develop any new state-of-art motor control algorithms, which you can integrate to the specific motor and conduct experiments to study the test characteristics as well. That's what briefs you an idea of this test setup. As a part of this lab, we have a more advanced dyno setups. We can also have a very lower side of the dynos as well, where we can have a load that can be something like an eddy current dyno. So as a part of that, the load will be replaced by an eddy current. So, but you will not be able to conduct a transient test cases. You will have a limited test cases. Also in cases you can replace that 4-quadrant load even with an option of a rope brake dynamometer as well. But this is the most advanced one where you will have all the options to conduct, like you can conduct even the real-time road load simulations as well, That means we can vary the torque continuously with respect to a given requirements, so that you get to know to operate the motor in a realistic conditions and come to a conclusion that how the motor behaves in real-time conditions and what is its longevity, what is its performance, and various different parameters in place. So thank you very much.